Today we're taking a look at rate of change. And there are lots of different ways to think about the idea of rate of change. One of the definitions is vertical change over horizontal change. And we sometimes think of this as change in the dependent variable, or y, divided by change in the independent variable, or x. So we're going to take a look at the rate of change in a few different scenarios. First, we have this table off on the right. It's called the cost of renting a computer. And we can see in the left, the inputs are the number of days, and the outputs are the cost of a rental charge. And we're asked, is the rate of change for each pair of consecutive days the same? So let's take a look. We know that it's change in y divided by change in x. So if I look at the change in the outputs, the y's, from 60 to 75, we see that going up by $15. And that's in a change of 1 day. So if we look at the change in y over the change in x, in this case, that would be $15 per 1 day. And then we need to look down the chart and see if this remains consistent. So the next change goes from 75 to 90. That's again an increase of $15 for 1 day. Looking at the next change, $90 to $105 is $15 per 1 day. And finally, $105 to $120 is $15 increase per 1 day. So we can see that yes, this rate of change for each pair of consecutive days is in fact the same. It says, what does this rate of change represent? In other words, if we think of it in terms of the problem, what does 15 divided by 1 mean? This means that the rental charge increases by $15 each day. So that's taking the math of a rate of change of 15 and explaining it in the context of the problem. Now, when we have a rate of change that's constant, it's exactly the same every time, it gets a special name called slope. There's no big difference between rate of change and slope if we're talking about a line. But if we talk about other types of graphs, which you'll do like in Algebra 2 and future math classes, the rate of change will not always be the same. But we spend a lot of time talking about slope in Algebra 1. So we start looking a little bit more specifically at how can we actually calculate this. So notice vertical change over horizontal change is the same as up above. But when we talk about how do I calculate the change in y, that's what we call the difference in the y values. So when we were up here looking at this problem and we said from 60 to 75, how much is that? Well, we could have done 75 minus 60 to get the 15. So that's what we mean by the difference in y values. And then the difference in x values is that change in x. So when we looked at how much did it change from 4 to 5, we could have said 5 minus 4 is 1, so the change in x was 1. When we start putting this on a graph, you'll see why we sometimes use the phrase rise over run, but until we start looking at a picture, that part won't make that much sense. So let's start with this formula. It says the slope of a line that passes through the points x1, y1, and x2, y2 is given by the slope. We tend to use the variable of m. I know that sounds crazy, but that's the variable we always use. Is change in y over change in x, and here's how we can calculate it. We can subtract the y values, subtract the x values, and then make a fraction out of it or divide it. So let's take a look at how we would do that. Calculate the slope of the line containing the points 2, -6, and -3, 8. So we can think of this first point as being the x1, y1, and the second point as being the x2, y2. Remember, the slope formula says that we're going to take the difference between the y values. So 8 minus a -6 and divide that by the difference between the x values. I need to go in the same order. So since the 8 came first, the negative 3 needs to come first. So negative 3 minus 2. 8 minus a negative 6 is really 8 plus 6, or 14. And negative 3 minus 2 is negative 5. The only thing I would change about this for my final answer is I would sneak that negative out in front of the whole fraction, because we don't really leave negative signs in the denominator, but 14 and 5 don't have any common factors, so we can't reduce it any further. So the slope of this line is negative 14 fifths. That's the rate of change. Looking at another one, again, I can think of this as x1, y1, and x2, y2. So I'm always going to take the numbers from the second point and subtract the numbers from the first point. So my change in y over change in x, change in y is 2 minus 2 over change in x, 2 minus a negative 3. Well, 2 minus 2 is 0. And 2 minus negative 3 is like 2 plus 3 or 5. So we need to stop and think about this for a minute. If I have 0 and I divide it into 5 equal parts, each part has a size of 0. So 0 divided by 5 is just 0. So that's kind of interesting as a change in y over change in x. It says we would go up 0 for every 5 that we go to the right. Well, that means we're never going up. We're just moving to the right. So a rate of change of 0 is going to look like a horizontal line. Anytime we do this slope calculation and we get 0, the line is going to be horizontal. Now, I'm sure you can imagine a situation where maybe you do out that slope formula, and instead of getting 0 over 5, you get 5 over 0. Well, we know that you can't actually divide something into 0 parts. If you have something, you have at least one part. So that's what we call undefined. That's mathematics that can't be done. So when we have that situation, that line is going to look like a vertical line. It always goes up, but it never goes to the right or left, and that's exactly what a vertical line does. The other two possible scenarios for what do lines look like is they can have a positive slope, and that's the slope that moves up as you read from left to right. Or we can have a negative slope, which is a line that moves down as you read from left to right.